Hi there, good day. Welcome to this 9-line Change the Way We Code series. In this particular video, I'm going to talk about a very simple data structure called linked list and how to write it in a different way in C++. So before going further, I just wanted to let you walk through the existing way of writing the code. So the data structure looks like this. We always create a node, whatever it contains, and an next pointer, and we add the item into linked list by assigning the next pointer to next node, and so on. If you want to delete something from the linked list, you will just remove the node and just point the pointer to the further node. And this is the way a simple code is written where we have a list which is having a value, or just for example, and this is the next pointer. We can have a create list function which can create a new list and returns the new list. After that, we can have insert into list function which check to the list till we reach the next pointer, and then we create a new list. And finally, we can have a main program where we just create a list and we can insert anything into the list. So if you look into the code, this is the code V is there. So we create a list and insert into the list. There's a function, accessory function, not interested right now. Remove from list, where we just go into the data one by one and we'll see it later. And this is the main function. So if we just make the max entry as 10 and we just build it, and then we'll see how the list is created. I'm just trying to build it, so it's built, and just to see it, I'll just put a breakpoint over here, so that we can just pause into the program and then we can see it. So this is the watch window, and if you want to see the list, let's say my list. So if you see the my list, the first data is 0, next data is 1, after next 2, and if you go further, the next will go till 6, 7, 8, 8, and 9. Okay, next will be null. So this is the way existing linked list is created. And so let's look into the new way. That's what we are propagating as part of change the way we code. Before I show you how to write it in a new way, just a small introduction why we need to do something like that. See, if you pick up any data structure book, a very good data structure book, which is still being taught in the schools and colleges, they are written almost 20 years back, and many things have changed. The hardware speed is much more. You can afford to perform some extra instructions. The memory availability is not that bad now, and especially especially to the desktop kind of system, we have a large number of memory available, though it's not unlimited, but still the concern is less than, because earlier we used to have in kilobytes, now we at least have in gigabytes. So this is the way we are going to change the code. Like here we will not have a next pointer, so let's see how to write it in the code. For the sake of it, I'll comment this code. By the way, I'm using Visual Studio 2015 in case you were wondering. So yes, so let's create a list. I'll create a list. I'll have a val on that, and I'll not have anything. After that, we just like we have a create list in the earlier example where we are creating a list. We'll create a new list in this example in a different way. In this example, what we will take, as usual, this function will return a list. What we will take over here is that list, the first value of the list, something called as a reference, I'll take something called list counter. We'll come to know what it is, and list size. So now I implement this as I'll create a list new list equal to new list, to the size called list size. So basically, instead of creating a linked list, I have created something whose size is determined in the beginning. Don't worry, I'm going to talk about how to increase or decrease the size, but this is the way I come up with a random size based on my whatever algorithm or whatever analytic that this is the size I need, and I come up with this size. And now what I'm doing is that I'm in the new list, I'm initializing the new list, something called list counter, and incrementing after initializing and val as list value and return the list, new list. So this is the way I'm creating a list. So if I had to create a main function, I'll do it like this. In main, return 0 for avoiding compiler. I'll have a list counter, which is initialized to 0, and I'll define a size as define max entry as, let's say, 10. And here I will also create a list, list star list equal to, I'll call this function called create list. In this create list, first value is 0, second is the list counter, and third is the max entry size. So this list I got it. Now I can have a for loop in ctr equal to 0. In C++ 14 style you can use auto, which is a preferred way of doing it, but just not to confuse you with this, I'm just using it. So here is that what I will do here, insert into list function I will call, where I will insert the value which is ctr. I'll start inserting it from 1, it's a sequential value. I'll start with the ctr, and what I will do, I'll also enter list counter, and I will also pass the list over here. Okay. So this I will implement, but let's go to the PPT. We had a insert into list function like earlier, where we just loop through the null pointer and then at the end we create. Here we are doing it in a very simple way. You can see that I'll just create this function as void. Let me copy paste to avoid any spelling mistake, and I'll take a list pointer which I'll call the list, or I'll say int list counter int new val. Is this the way, or no? No, it's you can arrange it in any way, so that's not a problem as long as it's been passed. So here what I will do is the list, I'll take the list counter, increment it after assigning dot val and its new val. It's a single line of code. So this will increment after assigning it, and that's the way I'll do it. So if you write the main program I have already written, it's being shown here. And just to show you in the, just let me compile it first. It's compiled, yes, and I'll put a breakpoint again over here and just wait it. So the list name is here lst. So one good thing about arrays is the dynamic array is that in Visual Studio, if you just write the number, it will show you the 10 value. So you can see the 0 to 9, 10 element, this is having 0 to 9. So we have created actually a linked list with 10 elements. Now let's move further. We'll talk about removing an item from the list. So it's slightly different than what we used to do in the linked list. If you look into this existing code over here, where we just iterate through the list and rearrange the pointer. But here we'll do it something different. Let's say this is our list with 10 elements. I want to remove 4. I'll find where 4 is and I'll remove it. Remove means just remove the value. Don't need to remove this memory. After that, to prevent fragmentation, I'll shift all of these items to 1. And this is the new array. So it will always be whatever memory items are there in the list, it will always be in the contiguous memory location. And this is the way the code will be written, like remove from list. When you find the list, you just uh, do a single statement of mem copy and then assign the last value, it's some undefined value, and then break it. So let's write it. So if I just want to write remove from list, I'll again take the list pointer, int I'll take a remove file. Here let's take a list counter anyway, and then take a remove file. So let's implement it. So I'll say for int ctr equal to 0, ctr is less than list counter, say ctr plus plus, and if the list ctr dot val is equal to remove val. So this is the one which I want to remove. Then what I will do, I'll do mem cpy, this is the destination, the list ctr. In this, copy whatever is there one memory ahead of this ctr plus 1. Then how much? If you see it, it says size, how much. So it will be, basically it will be list counter is the number of count minus your ctr plus 1, okay, into, size of whatever list is. Done. It is slightly small. So what I have to do, I have to mem copy this here, this here. Okay, this is done. Then we have to make sure that list counter is also decremented, and setting the last element to some undefined. Let's say -1. I put 0 over here, but let's say -1 is something undefined, declared undefined, and break it out for me. So let me call this remove from list. I'm passing the list. What is the second one is list counter. And this is just for demonstration purpose, guys. So the parameter might be here and there, but just to let you know the intention. So let's go what I want to let's say 8. So let me compile it. Let me see if it compiled. Looks like yes. And now let's go through the breakpoint remove from list. What happened is that, so here is my list with 10. So if I want to remove 8, so basically 8 will be removed, 9 will come here, and it will be -1. Let's go just one step further and see if it happens. Yes, it happens. So basically if you see list counter is actually 9. I'll show you again. I'm again running in debug mode, this thing. So list counter is 10. I want to remove 8. I managed to do it, and the list counter is again to the 9. Fine. So let's move further. So there is, you have created a list with a predefined size max entry. Okay, what is needed if we need to increase the size? So it's very easy to increase the size, and here is the logic about it. Here are 3 steps. Create a new array of size. You can do 1.5x. Let's say if there are 10 elements, you can say new size will be 15. I'm just taking it as 2x example. Copy existing element and delete the old array. So basically this is the way. If you have this one, you just double the size and create an empty one, and just copy this and delete this old array. So this is the just a simple thing, code how to do it, and maybe I'll just write it. So list. It will also return list. Increase the size. What's the name of increase list size? Increase list size. So I will say list again. I have to pass the list, and again in list counter and new size. So I'm not going to do any check over here. I'll just create list star new list equal to new list new size. Okay. What I will do, mem copy in new list. I'll copy the list of the time list counter, and I'll just return. So this I'll just return this new list. And let's say here I want to create a new list of size 20. So this new lst equal to increase list size the list counter new size is 20. Let me just compile it. Looks like some problem. The list, okay. Now lst, it's compiled. So I'll just put a breakpoint over here. So if I just print it over here and I say new list 20, so it's undefined. If I just press it, yes, ideally it should copy everything. So something, yes, so it should be size of list. Let me compile it again. Successful. And let's go here again. We'll see this. Yes, 9. They are garbage value. You can rename CPI with 0. So we have new list. Okay, and that has increased the size. It didn't disturb our list counter, and we can continue like that. So this is the way we can increase the size. Similarly, we can decrease the size. The very simple way is that, let's say after some time you are removing the element in the list and you are left with some empty memory blocks. You can create a new array of smaller size, copy the elements and delete the old array. Now come to the benefits of doing these things. See, the linked list I believe is one of the worst data structure because it is not possible to do any search other than a linear search on it. But if you implement the linked list kind of behavior in an array, the things can be accessible easily because it's located in contiguous memory location. Second benefit, if it is array, it can be sorted. You can apply any sort, merge sort, quick sort, or heap sort, or for that matter insertion sort to get it sorted. Once sorted, we can access the data in the logarithmic time. So no matter how big the linked list become, the search of the data can always be logarithmic because you put data in linked list to get it retrieved at some point of time. So that's the way we should write it. There are memory, I mean, there was some processing overhead. It seems to be here in this case, but it's not the case. Remember, when you create a linked list, every time you are calling new, which itself is a very big overhead, and it may be 100 200% more overhead than what we are doing with array. So that's pretty much it. I would like you to use the way we and propagate the change the way we code because we really need to change the way we code in today's environment. Thanks a lot. Thanks for listening. Don't forget to follow.